So, top of page 40, under the red word populations. Remember from your reading that a population consists of all the organisms of the same species living in the same area at the same time. That was our bell ringer question. We should all know that. For example, all of the pythons living in the same rainforest would be a distinct population. There are several things that can change a population's size. That's what we're going to get into today. To highlight, let's highlight the answer to our bell ringer. To repeat, a population consists of all the organisms of the same species living in the same area at the same time. So out of the several things that can change a population's size, the first one we're going to get into is births and deaths. New individuals generally join a population by being born into it. A population grows when more individuals are born into it than die in any period of time. If we think about that, that should make a lot of sense. If you are adding something to a group or to a population in this case, the number should get bigger. If you take it away, it will get smaller. But if we're adding more than we're taking away, when those happen at the same time, our overall number should increase. So with the birth rate, the number of births per 1,000 individuals for a given period of time is greater than the death rate. A population may increase. When the birth rate is the same as the death rate, the population usually remains stable. What does it mean when it says the population will usually remain stable?
Like, there's still be enough resources for everything, and like the population will stay the same.
Population will stay the same. That's the important part. Yeah, so just like we said, if we're going to add more than we're going to take away, it's going to go up. But if we're going to add and take away the exact same number, then our overall population size isn't going to change much. It's going to stay relatively the same. And then off of that, in situations where the death rate is greater than the birth rate, the population will decrease. Which is what we've been saying the past few minutes. If we take more away than we add, the number should get smaller. Go over to page 41. Immigration and emigration. A population size also can increase or decrease when individuals move into or out of the population. Immigration means moving into a population. An easy way to remember, immigration starts with an I. So does into. That's how we can keep those together. Emigration means leaving. Same type of thing. Emigration starts with an E, so does the word exit, which means to leave, to go out. Let's talk about this for a second. If animals are immigrating, right, going in, what's going to happen to our population size? Let's show with our thumbs. Is it going to increase or get bigger? Decrease, get smaller if we are immigrating. I. Everyone should have our thumbs up. It should be getting bigger. Opposite of that, if we're emigrating, beginning with the E. Keep up this word. Should we be increasing or decreasing? Right, we should all be decreasing. We should be getting smaller. For instance, if food is scarce, some members of the antelope herd in figure 4, down below, may wander off in search of a better habitat. If they become permanently separated from the original herd, they will no longer be part of that population. If they are permanently separated, they will no longer be part of the population. Yes. Can you wait just a few seconds till we're done with this? Okay. So, it says that they will no longer be part of that population. Can someone raise their hand and tell me why they will no longer be part of the population if that happens? You go.
Because they wandered off and the population said, no, we're gonna take you back.
Right, they wandered off. If we look on page 40 at our definition of a population, that means it's in the same area. And if we take a group and they separate themselves, they're no longer in the same area, which means they're not going to be part of that same population anymore. Any questions on that? Good. Okay, let's skip population density for a second. Let's go down to our reading check. How do birth and death rates affect a population size? We went over this. Let's do birth rate first. Someone raise their hand, tell me. Birth rate, how is that going to affect a population size?
Either less or making more.
By increasing it, yes, by making more. Opposite of that, death rate. Parker, you're back there.
It's decreasing.
Decreasing. Okay, let's go to the right just a little bit more. We have a question on emigration. Food scarcity is just one cause of emigration. What other factors might cause individuals in this antelope herd to emigrate? Weather, that's one. What are some other factors that will cause to leave? Prey or predators? Yep. They would be the prey in that case. They're leaving because someone else is coming in and trying to hunt them. You said what? Sorry, I can't hear you. Water? Yeah, so lack of water. Anything else? Yeah. Not enough food source. Food scarcity is the first one it gives, but yes, that is correct. Anything else? What about space? What about a place to live? If there's a lack of space, they will need to leave to find more space, right? Okay, so lack of space will be one as well. Any questions? Okay, let's go back to page 40. Let's look at the graph on the bottom of page 40. We're definitely going to need to know how to graph. So, highlighters down for a second. Let's pick up a pen, pencil, whatever you have. We can't make them that thick with a highlighter. So, number one here, it says use the data table to complete a graph of the changes in the deer population. So, we look at our table up here with all of our numbers. This first column here is the year. The second one is the population number, the population size. So if we're going to graph this, how would we graph this first number, this population size in the year 2000?
Yeah.
We would go on the bottom here on the x-axis where it shows year. We'd find the year 2000. And on that line, going vertically, we would put a dot where 525,000 would be, which is in between 500,000 and 550,000. Well, what is the population? It has to be in the same area, right? And over here it says in Ohio. So, let's graph all these. In 2001, the next one, it's 560,000. 2002, 620,000. 2003, 670,000. In 2004, 715,000. 2005, 720,000. What has the graph done so far? It is increasing so far, yes. 2006, 770,000. 2007, 725,000. What happened there?
Decrease.
A small decrease, yes. 2008, 745,000. 2009, 750,000. 2010, 710,000. Let's connect all of our dots. So after we have that graph copied, question 1 asks, describe the trend in the graph. Someone raise their hand, tell me, what is the overall trend in the graph? Someone who hasn't answered a question today, preferably. AJ, you've already answered today. Someone who has not answered a question today. I will draw sticks if we have to. I don't like drawing sticks, so someone tell me. Am I gonna have to draw a stick? All right.
It's right there.
She already got him over here. Carter. What is the overall trend in the graph? It is increasing, yes. So our trend over here on number 1 is an overall increase. Number 2, what factors do you think might be responsible for the changes in the deer population? So what factors caused this to increase? We just talked about a few of them. Yeah.
Lack of space.
Would a lack of space cause an increase or a decrease?
Decrease.
That would cause a decrease. What did our graph do? Increase. So not a lack of space, but maybe what's the opposite of a lack of space?
More space.
Maybe there was more space. We can put that. Maybe there was a ton of space, right? So it could hold more deer. And what would that be called if more deer moved in? Immigration. What are some other ones? Less predators. That would probably cause immigration. That probably cause them to move in. But what would What would predators do? Predators would cause death, right? So what is the opposite of death?
Birth.
Birth, right? So a higher birth rate. A higher birth rate than a death rate. Let's get one more. More water, more food, yep. More food and water. Let's turn our page, let's go 42. We're gonna pick back up our highlighter.